Today we're going to start the last section that we're going to cover this semester, and this is section 11.5, entitled Valid Argument. So we're going to learn what it means for an argument to be valid. Now, there is on page 515 of your textbook, Table 2, which lists the templates for logical arguments, the different things we're going to base a logical argument. And I'm going to write the table in completion because we're going to use it several times today. P implies P or Q. This rule is called addition. 2. P and Q implies P. This rule is called simplification. 3. P and P implies Q implies Q. This is called modus ponens. 4. P implies Q and not Q implies not P. This one is called modus tollens. 5. P or Q and not Q implies P. This one is called disjunctive syllogism. 6. P implies Q and Q implies R implies P implies R. This is hypothetical syllogism. The hits just keep on coming, don't they? 7A is P implies Q and R implies S implies P or R implies Q or S. And B, P implies Q and R implies S implies P and R implies Q and S. These are called constructive dilemmas. So is this not the biggest ragtag group of names for things we've ever seen, right? We've got some Latin phrases in here. We've got modus ponens, modus tollens. That's clearly Latin stuff going on. But the last one is called constructive dilemmas. We're not even, like once we start going Latin, shouldn't that be constructive dilemmae or something like that, right? I mean, this is just getting out of control. But those are the arguments, those are the basic building blocks of what's going to be a valid argument. So we're going to show examples of how to write or check if something is a valid argument, which is mostly what we're going to do. So I'm going to write down an argument as follows. If Marvin studies math, then he is smart. Marvin is not smart. Therefore, Marvin does not study math. This seems valid, right? If I just say, this is not so complicated an argument that when I just state these three statements, this seems suspicious, right? If Marvin studies math, then Marvin is smart. Marvin is not smart. Therefore, Marvin does not study math. But let's see how this fits in with this list of rules of inference, 1 through 7, that we have above. Well, we need some P's and Q's. P is going to be Marvin studies math. And Q is going to be Marvin is smart. Okay. So, step one says P implies Q. If Marvin studies math, then he is smart is the same thing as P implies Q. So this is assumed to be true. The second thing that we assume to be true is not Q. Marvin is not smart. Okay. And then step 3, we have P implies Q, and at the same time we have not Q. Okay. That implies not P by Modus Tollens above. Right. See this fellow here. P implies Q, and not Q implies not P. So we have just now validated the argument that was written down at the beginning. We've used these rules of inference to validate the argument. So let me say what an argument is, and then we'll do some more argument validation. An argument is a set of statements H1 through Hn called the hypotheses. If these are all true and C is a conclusion, then the argument is valid if, assuming all of the hypotheses implies the conclusion. That's what it means for an argument to be valid. Going back to the previous example, the first hypothesis is if Marvin studies math, then he is smart. The second hypothesis is Marvin is not smart. The conclusion is Marvin does not study math. And we were able to take the fact that the two hypotheses were true and use one of the rules of inference to show that the conclusion was true. That's the idea. So I'm going to write another argument, and we're going to try to show that it is valid using these rules. Any questions before I do that? Okay. Suppose these three statements are true. 1, oil prices stay above $50 a barrel, or I will sell my Exxon stock. That's the first statement. Second statement, if oil stays above $50 a barrel, then hybrid car sales will not decrease. If oil stays above $50 a barrel, then hybrid sales will not decrease. And the third one is hybrid sales are decreasing. So these are the three hypotheses, and the statement we are going to prove is I will sell Exxon stock. So we want to prove that conclusion from the three hypotheses. Okay, so I am going to call the statement oil prices stay above $50 a barrel O. And I'm going to call I will sell X on stock S, and I will call hybrid sales are decreasing H. All right, so this is my O, this is my S, and this is H. Okay, so here's what we do for the argument. First thing we do is we write each hypothesis down. The first hypothesis, oil prices stay above $50 a barrel, or I will sell ox on stock, will be stated O or S. And over here in another column, I'm going to write hypothesis. I want to use a reason for each of the steps that I take. Okay, secondly, I have O implies not H. If oil stays above $50 a barrel, then hybrid car sales will not decrease. H is hybrid car sales are decreasing, so not decreasing is not H. This is also a hypothesis, and the next thing I'm going to put down is a hypothesis as well. H. Okay. 4. Okay. I can conclude from the fact that O implies not H and that H is there, I can conclude not O. Let me scroll up to the valid arguments. Let's think about which of these arguments could I use to do that. Which of those 7 can I use to show that if O implies not H and H is true, then I do not have O? We see which one it is. It's a little bit hidden. Okay, it's going to have to be one of the ones with implications in it. Let's look at number 4. We have P implies Q and not Q implies not P. Ours is O implies not Q, O implies not H and H. So it's the same thing as Modus Tollens, except we switch the role of Q and not Q. It's the same thing. So the reason for this, we would say, is Modus Tollens. And we maybe put a 2 and 3 in parentheses to say I'm using hypothesis 2 and using hypothesis 3 for this statement. Now, I want to conclude that the Exxon stock will be sold. I want to conclude now S. Okay. Let's go back up and look at these things. Let's look at this disjunctive syllogism here. P or Q and not Q implies P. So if we have an or statement and you know one of them is false, then the other is true. That's what the disjunctive syllogism is. So let's look and see that down here. We have an or statement, O or S. See, number 1 is O or S. But we have number 4, not O. So if you have an or statement and one of the 2 things you know is false, then the other one must be true. So then S must be true. So this is disjunctive syllogism. And I'll put 1, 4, because I'm putting 1 and 4 together to get that disjunctive syllogism. What do we think? This seems a little bit tough, right? This is a little tough. Okay, so you absolutely are going to want to have those 7 things, or 8 things if you want to count 7 as 2 of them, on your little study sheet, right? Because if you're going to have to come up with a valid argument on the exam on Wednesday, you're going to want to have those logical inferences there, right? Okay, so let's take a look at another one. Or let me just pause. Are there questions about the one we just did before we move on? I don't want to move too quickly. Kayla.
I'm confused. Like, what is your final statement then? Like, how did you get to that point?
Well, the final what I'm trying to prove is I will sell X on stock. So my last line should be the statement I will sell X on stock, which is exactly what S is. So basically, I'm trying to prove S. Once I give everything in their names, now I want to prove S. So I want to keep doing steps until I can get to S. Does that answer the question?
I just don't understand how you got to S.
Okay, because I know that because there's 2 things happening here. I know that I have sorry, not that one. I know that O or S is true because that's one of the hypotheses. Either oil prices will stay above $50 a barrel, or I will sell the X on stock. That's the first hypothesis. We know that hypotheses are assumed to be true. That's probably what the word hypothesis means in Greek, something that is assumed to be true. So I assume that one of the 2 or both of O and S are true, and I do some logical inference, and step 4 says, look, not O is true. So if not O is true, and O or S is true, then S must be true. So that's where we get step 5, S. Now, what is the reason why that's a logical step? That goes back to the table. That's the disjunctive syllogism. That says if you have an or statement and you know one of the 2 things is false, then the other must be true. That's what disjunctive syllogism is. Has anyone taken like debate class or something like this before? Do they do that anymore? No, there's no debate anymore, right? We don't debate things, we just order them. Okay, so these are sorts of things you would probably learn in a debate class, how to construct a valid argument. Okay, let's do another one, and I'll try to move slowly again. Okay, we're going to show the following argument is valid. We're going to suppose I study math or econ if I have to take English, then I do not study econ, and I do not study math. Therefore, this is what we're trying to prove, the therefore statement, I do not have to take English. Okay. So we're going to have 3 statements here that we're using, and then there's compounds of them. The first statement, M, is going to be I study math. The second statement, C, is going to be I study econ. And the third statement, E, is going to be I have to take English. Okay? So we got to name everything first before we can really make progress, right? Because we're going to use the logical inference table, and that needs variables in order to confirm it. So the first thing we do is name the things that need to be named. So I've named things, and let's write out what these 3 statements are, these hypotheses now. We write the hypotheses. The first hypothesis is M or C. I study math or econ is the same thing as M or C. And the reason this is true is it's a hypothesis. And I can neither say hypothesis nor write hypothesis. Okay. The second hypothesis is E implies not C. If I have to take English, then I do not study econ. This is also a hypothesis. 3 is I do not study math. That's not M. Now, I am trying to show, eventually, I do not have to take English. I'm trying to show E. But look, if I put 1 and 3 together, what can I conclude if I put 1 and 3 together? Yes?
C must be true.
Yes, exactly. We must have C because we have M or C and we have not M. So therefore we must have C. And this is again the disjunctive syllogism. Okay. Now, if we have C and at the same time E implies not C, what can we also conclude that we have? I don't care if you know the name of it yet, but what can we conclude? If we have C, number 4, and we have E implies not C, number 2, what can we then conclude? If C is true, and E would imply not C, what can we therefore know about E? Keegan? It's not true, so therefore E is not true. Okay, but what is the reason for that, right? We want the logical implication, or the logical inference rule that says that. That is the Modus Tollens rule. That is the one that says, I'll write it down again instead of scrolling up. It is that P implies Q and not Q implies not P. Okay, and we've used here 2 and 4 in Modus Tollens. Okay. So when we are validating an argument, what you need to do is you need to provide a list of things and a reason for that list. And the reason has to either be hypothesis or one of the logical inference rules. Okay, there's one more method of proof that I want to talk about before I give the assignment, and this is called indirect proof. The way we do this is we can show an argument is valid, meaning a bunch of hypotheses imply a conclusion, by assuming C is false and showing then that at least one of the hypotheses is false. This is called indirect proof. You can show, and you can also show, not just by making these deductive steps, we can also show that a set of hypotheses implies a conclusion by assuming that the conclusion is false and showing that that finds one of the hypotheses false as well. Okay, we're out of time today. The homework is 4, 6, 12, 14, 16, 18, and 22. Okay, this is due Monday. Monday in class, we're going to do review. So if you're stuck on one of these, we'll definitely talk about it Monday in class. This will be on the chapter exam, so make sure you figure out how to do this stuff. But then on Monday, we'll do any sort of review so any problems you want to talk about from the exams, the sample exams, will be a great thing to ask about on Monday.
What's the exam?